Okay. Good morning. Good morning, grade 11. Now, inshallah, we are going to complete, inshallah, our previous session. That's called Let's talk about spontaneous processes. Okay, spontaneous processes. What about spontaneous processes? Okay, listen please to this audio.
Spontaneous processes. Assuming no change in physical state occurs, the entropy of a system usually increases when the number of gaseous product particles is greater than a number of gaseous reactant particles. With some exceptions, entropy increases when a solid or liquid dissolves in a solvent. The random motion of particles of a substance increases as its temperature increases.
So we explained this slide before in the previous session, and we feel that's according to spontaneous processes. Okay, there is no change in physical state occur. The entropy of a system usually increases when the number of gaseous product particles is greater than the number of gas reactant particles. Okay, and with some exception, entropy increases when a solid or liquid dissolves in a solvent, and according to the random motion of particles of a substance increases as its temperature increases. Okay, so we're going to complete as in this case. It's called free energy. What about free energy? According to entropy, the universe and free energy. What's meant by free energy? Free energy, it means that is the energy that is available to do work. Is energy that is available to do work. Okay? If the sign of free energy change, delta G, delta G, if the sign of free energy, delta G, is positive, the reaction is non-spontaneous. So if delta G is positive, so it's called non-spontaneous. But if the sign of the free energy changes is negative, the reaction is spontaneous. Okay, is spontaneous. The entropy of the universe equal what we studied before, that universe includes system and surrounding. So the entropy of the universe, which means system plus surrounding, always increases in any spontaneous processes. In any what? In any spontaneous processes, as Gibbs free energy equation. What about the Gibbs free energy equation? Delta G system equal delta H system minus T delta S system. As we said, that symbol of delta G system is represents the free energy change. Represents the free energy change. But delta H system represents the change in the enthalpy. Change in the enthalpy. And T is a temperature. Delta S system represents the change in the entropy. Change in the entropy. So the free energy or absorbed, released or absorbed in a chemical reaction is equal to the difference between the enthalpy change and the product of the change in the entropy in joules per Kelvin. Its measuring unit, joule per Kelvin, and temperature in Kelvin. It's okay. Listen please to this audio.
Entropy, the universe, and free energy. Free energy is the energy that is available to do work. If the sign of the free energy change, delta G degrees, is positive, the reaction is non-spontaneous. If the sign of the free energy change is negative, the reaction is spontaneous. The entropy of the universe, system plus surroundings, always increases in any spontaneous process.
Okay, so that this video, go to your connected ED resources to play interactive. Okay, let's go to Macro Health site. This video talk about the reaction spontaneity. Delta G system, we said before that equal delta H system minus T delta S system. So if delta H system is negative, was negative, so delta S system will be positive, delta G always negative. Okay, so the reaction spontaneity is called what? Who can answer me? Who can answer me? Okay, الوليد. Walid, can you answer the first question, please?
What is the question?
This is, do you see it or no?
I don't see it. Maybe I should leave and come back. Is that okay, or did you lock it?
Did you see it now?
Yes, yes.
It's okay. It's okay. Negative, it's okay. This is negative. Delta H system. Delta H system, negative. Okay, delta H system is negative. And
Yes.
Delta S system is positive. Delta G system will always negative. So this reaction spontaneity, okay, you have choice if spontaneous at lower temperature, never spontaneous, always spontaneous, spontaneous at higher temperature.
Spontaneous at lower temperatures.
Lower temperature, it's okay. We are going to submit the answer after finishing this quiz, okay? Thanks, Walid. Khalid Harbi. Second question,
Yes,
Khalid.
Mr.
Second question.
Okay. Negative with negative, negative or positive, it's gonna be spontaneous at lower temperatures.
Okay, but we chosen it.
I think the answer of Walid is the second, for the second one.
For the
Not for the first.
this is second one.
Yes, I think. This is my answer.
This is your answer, okay. And the first one will be what?
Always spontaneous.
Always spontaneous. Okay, we are going to know the best answer after finishing this quiz. Okay, thanks, Khalid. Hussein?
Yes.
Is Hussein third question? Positive,
Okay.
positive and
when the-
positive. Negative or positive. So it will be what?
Spontaneous at higher temperature.
Spontaneous at higher temperatures. Okay, so the last one is positive. A is always positive, so it's never spontaneous. Okay, we are going to make submit for this quiz to know the best answer. Yes, it's okay. It's okay. Good, Khalid. Good, Khalid. Excellent. That negative when delta H system is negative and delta S system is negative, so delta G system negative or positive, it will be spontaneous at lower temperature. Spontaneous at lower temperature. But when if it was always negative, so it will be always spontaneous. Okay, and thanks Hussein. Okay, and thanks for me for choosing the best answer of the last question. Okay, thanks guys for your participation. It's okay. So we're going to complete our session. It's okay. Okay, in this question, okay, problem for a process delta H system equal 145 kilojoule and delta S system equal 322 joule per Kelvin is the process spontaneous at 382 Kelvin. So you must calculate delta G system to determine spontaneity. Okay, so the known T equal 382 Kelvin, delta H system equal 145 kilojoule, delta S system equal 322 joule, but the unknown is delta G system. How can we calculate it? First, convert delta S system to Kelvin joule per Kelvin. It's okay, kilojoule per Kelvin. So we are going to multiply 322, that's delta S, times 1 over 1000 to change it to kilojoule, from joule to kilojoule, okay? Because this is delta S system, 322 joule per Kelvin. And we must change it to kilojoule per Kelvin, so we are going to make divide by 1000. 322 joule per Kelvin divided 1000 to be 0.322 kilojoule per Kelvin. After that, okay, we must write the main equation, okay, or main rule. That's called delta G system equal delta H system minus T times delta S system. So substitute T equal 382, okay, and delta H system equal 145 kilojoule, and delta S system that we converted equal 0.322 kilojoule per Kelvin. So delta G system would equal what? Equal 145 minus, between brackets, 382 times 0.322 kilojoule. Okay, and after that, delta G system will equal 22 kilojoule. 22 kilojoule. It's okay. After that, because delta G system is positive, the reaction is non-spontaneous. Non-spontaneous. Why non-spontaneous? Because the reaction was what? Reaction was the reaction have a positive sign. It's okay. So after what? After that, because delta H is positive and the temperature is not high enough to make the second term of the equation greater than the first term. So delta G is what? Delta G is positive, and finally the figure are correct. It's okay. Understand this problem? Any question, guys, till now? Okay. After that, I think that we finished this lesson. That's the essential questions that we studied. Okay, listen to me to answer the question. Okay, we are going to answer the question about from McGraw-Hill about this session. Okay, listen please to this audio. Do this audio first.
Review. Essential questions. What is the difference between spontaneous and non-spontaneous processes? How do changes in entropy and free energy determine the spontaneity of chemical reactions and other processes? Vocabulary. Spontaneous process. Entropy. The second law of thermodynamics. Free energy.
It's okay. So I think that we ended this session. Okay. Now we are going to move to our McGraw-Hill site. Okay, to answer the question about this. Okay. Okay, listen, guys. Who can answer the first question? Khalid Manif. Khalid and Manif. Where is Khalid? Where is Khalid? I think that he left, but without taking any permission from me. Okay, Khalid. Mu'taz. Mu'taz? Okay, Mu'taz. Can you answer first question, please? Can you raise your voice, Mu'taz, because I can't hear your voice well.
Which of the following process occurs with a decrease in
In entropy, yes. Which decrease in entropy?
I think number C.
See?
Yes.
It's okay. As sublimation of dry ice, we're going to get the best answer after finishing this quiz. Okay, but your answer was C. It's okay. Thanks, Motaz. Number two, Khalid Khalid Harbi. Yes, Khalid.
Yes, Musa.
Number two.
According to change of state, why does the entropy of liquid water increase as it's heated?
Yes. Read read the fourth choice well, then choose your best answer.
The molecules get farther apart during heating. The heating mechanism become more disordered. There is greater random motion of molecules. The molecules get closer together during heating. I think it's B or C, but I will go with
B or C, assuming no change of state. Why does the entropy of liquid water increase as it's heated?
I will go with B.
B. It's okay. We are going to know the best answer at the end. Okay, thanks Khalid for your participation. Now,
You're
Hussein.
welcome.
Hussein.
Yes.
Okay, my friend. Can you answer question number 3?
Gas particles have more entropy when they can move freely than when they are dissolved in a liquid or solid. Which of the following represents an increase in entropy of the system?
Yes.
A. Soap pulp goes flat as carbon dioxide bubbles escape. B. Water in an aquarium of oxygenated by a bomb. C. Water vapor consistency of a cold glass. D. Oxygen is dissolved into your blood.
What's your best answer?
I think it's A. Soda pump goes flat.
Number what? Number D?
Yes. لا A.
Number A, soda pop goes flat as carbon dioxide bubbles escape. It's okay. We're going to know the best answer. Okay. Thanks, Hussein. Al-Walid. Al-Walid, can you answer fourth question? What is Al-Walid?
Hello.
Hello, Walid. Can you answer the first question, please?
Exothermic chemical reactions accompanied by an increase in entropy are all spontaneous.
Exothermic means have negative sign or positive sign?
I'm
Exothermic.
not sure, but I think it's positive, right?
No, exothermic means negative. Exothermic
Okay.
that produce energy as a result of the reaction.
Okay.
So it will be what? What's your answer?
Will be it will be non-spontaneous.
Non-spontaneous. It's okay. We're going to know the best answer. Okay, the last question. Who can answer the last question? Khalid Munif, you joined again or not? If you joined to our session again, can you raise your hand, please? Okay, so Khalid didn't join to us. Okay, who can answer the last question?
نعم يا مستر.
Where are you, Khalid? I said Khalid many times without any answer.
معلق عندي شوي.
Where are you, Khalid? Hello? Khalid.
أيوة يا مستر.
Where are you?
كنت بالحمام مستر.
Okay, but Khalid, I said before, Khalid, take permission for me, and I won't say no, but but must I know only. It's okay, Khalid.
صح والله.
It's okay. Can you answer my friend the last question, Khalid, please?
Okay, for a particular process,
Yes.
delta H system equals negative 160 kilojoule, and delta S system equals negative 400 joule per K. Find delta G system at 298 K. Is the
Yes.
process spontaneous? Okay, we substitute first.
Yeah, it's okay. You have the main rule that's called delta G system equal delta H system minus S delta S system. Can you answer it?
Okay, negative 560 equals.
If you have a calculator now, you can solve it easily.
دقيقة.
Okay.
والله يا أستاذ ما عرفت. هي spontaneous ولا لا؟ مش متأكد يعني.
It's okay. So what's your choice for your answer? Any answer?
أنا أقول B.
B. It's okay. You are going to know the best answer for this test. Okay. Grade the test. Okay. Best answer, question number one. Question number one, which will be freezing of water. Okay, freezing of water. Freezing, why freezing? Because it's called decrease in entropy. Decrease. So, since he said decrease, so the best answer will be freezing of water, not sublimation. Okay, okay, Mu'taz? Because freezing converts liquid water to solid water. Because order increase, this process has a decrease in entropy. The second answer, okay, second answer, A for Khalid, I think, assuming no change of state, no change of state. So why does the entropy of liquid water increase heated? The heating mechanism becomes more disordered, disordered. Okay, heating mechanism becomes more disordered. That the water molecules will be in a random way. So it will be disordered. As water is heated, the molecules move faster. The increase in random motion of the molecules increase the entropy of the system. Question number three only is right. Gas particles have more entropy when they can move freely, as Hussein said. Soda pop gas flat as carbon dioxide bubbles escape. Thanks, Hussein. Fourth question. Exothermic chemical reaction accompanied by increasing entropy. Increase entropy, and this exothermic الوليد. This is exothermic, so it will be spontaneous. And the last one for Khalid, okay, as by calculating this problem that I think you won't calculate it. So it will be negative 40.8 kilojoule, and it's called spontaneous. It's okay, it's called what's called spontaneous. Okay. Then thanks guys for your participation. Okay, and I'm pleased well by joining to our chemistry session. Okay, and you have the choice to join with me or not, but I think that you must increase from your knowledge, from your information. Okay, as this all information can't be repeated. Okay, it won't be repeated again in the next year, inshallah. Okay, so you must join to our chemistry session and get benefit from this information. Okay, thanks my participants, grade 11, and enjoy by your time. Ramadan Kareem, كل سنة وانتم طيبين, happy Ramadan. Okay, thanks guys for your listening and goodbye.